Okay, what I've got is a video here on graphing linear inequalities. So we're going to begin with this example, y is greater than 2x plus 1. Well, what we have is we have a bunch of coordinates on this coordinate plane that are shown here. Some of them are solutions to this inequality, and some of them are non-solutions. And so let me explain what I mean by that. Let's say we take the point 3, 2. We know that 3 is an x coordinate and 2 is a y coordinate. So what I can do is I can put them into this inequality and see if they give us a true statement. If they give us a true statement, they're a solution. So I'm putting 2 in for y and 3 in for x. And so is 2 greater than 7? That's what we get when we simplify this. That is a false statement. That means that this is not a solution to the inequality provided. And so let's pick a different point. Let's pick, say, this one right here, -5, +2, and let's do the same process. So I'm going to put them into my inequality of y is greater than 2x plus 1. 2 goes in for y, and -5 goes in for x. So then we have 2 is greater than -10 plus 1, or in other words, 2 is greater than -9. And this statement is actually true. Although 9 is greater than 2, you've got to keep in mind that's a negative, so it's going to be further to the left on your number line. So this actually is a true statement. So I'm going to show the true statement with a dot and my false statement or my non-solution with an X. And we could repeat this process, and we could find that there's a lot of non-solutions in this area, and then there's a lot of solutions in this area. And there's some boundary line somewhere where these non-solutions start working. And we just have to figure out where that boundary line is. What you would do if we repeated this process for all these points over and over again is you would learn that the boundary line would be y equals 2x plus 1. Okay? Just like we get from our inequality. We're pretending like this is slope-intercept form. So if I were to graph my y-intercept of 1 and do my slope of 2 from there, I could draw this dotted line, and what I would realize is everything on this side of the line gives me true statements when I substitute the values in for x and y. Or like we did over here, we got the true statement from that point. But all these over here don't work. So what we do, the way we graph these, is we just shade on this side of the line. I'm just shading where all of those points work. Now, let's talk about this more as like a three-step process, because obviously every time you're not going to want to try out a bunch of test points to see where the solutions are. So here's kind of almost a cheater method, okay? Step 1, that's going to be to graph your boundary line. Meaning I'm going to start by graphing this y is greater than 2x plus 1. So I'm going to get that y-intercept of 1, that slope of 2, and graph this line, okay? So step 2, we're going to shade. Meaning I'm going to shade, if I have a greater than or equal to, it's going to be above the line. But if I have a less than symbol or less than or equal to, that means we're going to shade below the line. And so this is what I call the cheater method. We could always test out points and see which side of the line the solutions are on, and wherever those solutions are, we're going to shade. But it's a little bit faster, and if you did enough of these, you'd realize the pattern that if we ever have that greater than or equal to symbol, we're going to shade above the line. If this symbol was the less than or or equal to symbol, we would shade below. And we'll do a few more examples to illustrate this in a minute. So there is step 2. I forgot to write my 2. In step 3, there's one last thing. We have to have either a dotted line or a solid line. I'm going to move up a little bit so we can see that. But basically, if I have these or equal to symbols, we're going to have a solid line. I'm going to explain what that means in a minute. But if we have just the less than or just the greater than without the or equal to, we're going to use a dotted line or a dashed line. And just what this means, if it's or equal to, that means points on the boundary line would give you a true statement. So in these situations, if I have these symbols, I would show that those points on the line work by making it a solid line. But in this case, we're strictly greater than that line. We're strictly above it. So I'm going to use a dotted line here to show that if I were to actually test out, say, this point that's on the line, it would give me a false statement. Let's do some practice. Here's our next example. And what we see here is we know that our step one is to graph the boundary line. However, here, our inequality is not in slope-intercept form. It's in standard form. So I'm going to copy it over here. And I've got to solve for y. And so hopefully you're okay at this process. If not, there's probably a series of other videos. I think I even have a video over this topic. I'm going to divide by 3 on each side. And we end up with y is less than 2/3 x minus 2. So we remember our step one was to graph that boundary line. So I'm going to go down to minus 2. I'm going to do my slope of, looks like a positive 2/3. And I'm just going to graph that line. Step two is figure out where to shade. We see this less than symbol, and if you refer back to those notes I had on the last page, I guess I can pull them up. This less than symbol means we're shading below the line, meaning all of our solutions, or the points that would give us a true statement if we substituted them in, would be on this bottom side of the line. So these are all the points that work if we substitute them in. These are all the points that don't work out here. And then our last step is to figure out if our line is dotted or solid. And here we have just the less than symbol. We don't have the less than or equal to symbol. We have the less than, so we're going to leave our line as a dotted line. And once again, just to remind you, that means that these points, like 0, -2, and 3, 0, those points would give us false statements if we substitute them into our inequality. Points on the line here do not count as solutions. Okay? I've got one last example, and then we'll be done. Got the same idea here. We have 4x minus 2y is less than or equal to 8. Well, once again, I've got to get it into slope-intercept form first. So I'm just going to solve for y. I'm going to divide by -2 on each side, and here is why I include this example. One thing that you hopefully learned about single variable inequalities, when you divide by a negative on each side of the inequality, or if you multiply by a negative on each side of the inequality, we're going to have to flip this inequality symbol. So it's now become a greater than or equal to. And then the negative divided by negative is a positive 2x, and then that divided by that gives us a -4. Now I want to stress, it's only when we multiply or divide by a negative on each side of the inequality. It doesn't matter if these numbers are negative. It's only that operation that we do to both sides. If that is multiplication or division, and if this is a negative, we have to change our inequality symbol. So now this is the inequality that we're graphing. I'm going to start at my y-intercept of -4 and do my slope of, looks like a positive 2. And so there's my first step. Second step is figure out where to shade. And now here is something else that's tricky. Our cheater method says that if we have the greater than or greater than or equal to, we shade above, but if we have these symbols, we shade below. However, if you look here, I've got the less than or equal to symbol in the original inequality, which would say shade below, but then when we flipped our inequality, it now becomes a greater than or equal to, which means shade above. And so a note that I'm going to add, this cheater method only works when the inequality is in slope-intercept form. Meaning we're going to look at the inequality symbol in this inequality. This is the one that's going to tell us how to graph. I can't look at the original and say we're going to shade below. It's got to be the inequality in slope-intercept form with y on the left and then mx plus b on the right, just like we have shown here. So, based on this, we got the greater than or equal to, we're shading above our line. And then we have the or equal to here. So for our step 3, the or equal to means we have a solid line. So I'm going to go back over my boundary line and make it a solid line. And that's just showing that points that fall directly on this line are solutions to the inequality. So there are 3 examples. Make sure that your inequalities in slope-intercept form, and if you remember these 3 steps that I've outlined right here, you should be good to go.